let's take a look at how Chapel was created, because open source kind of plays a big role in the fact that Chapel even exists in a way. So I'm excited to dive into that. And you kind of already described a little bit where the need to create Chapel came from in terms of having a language that was really suitable for supercomputers and large scale systems, while also being maybe a bit more user friendly than some of the other languages at the time. It might still have been a bit of a challenge to, let's say, convince a company that, hey, we actually really do need a new programming language, because I think you were at Calais when the idea came up, right?
Yeah, that's right. The setting was that I was a reasonably new hire at Cray, and I was put in charge of this question of how do we improve software productivity for supercomputers. And again, given my background, nobody would have been surprised. I said, oh, well, obviously, among other things, we should develop a new programming language. And at that time, I reported to the chief scientist at Cray, who was also the principal investigator for the DARPA program I mentioned earlier. And his immediate reaction was, no, I don't think we'll do that. I don't think we can do that. And I mean, he was polite about it, but his rationale was, he said, I think if we as a single company develop a programming language, it'll never be successful. And so why waste our time? And at that time, again, I was new to the job, still pretty new out of grad school. And who am I to argue with the chief scientist? So I was like, oh, okay, I'll go come up with some other ideas. But then as I stewed on it over the coming weeks and months, I realized that I could come up with languages that had obviously become quite popular that had started at a single vendor. So I think C is a great example of that. More contemporary for that time, Java had just been an example of that. And one of the great things about our chief scientist, who is a mentor of mine, was, he was the kind of person you could go back and say, I've been thinking about this, and I want to kind of challenge you on it, right? I'm not sure I'm convinced. And so he said, okay, well, tell me about it. And I sort of gave him my brief argument. He said, yeah, okay, well, let's think about this. Let's take the languages that we care about as a community, sort of the HPC community, and let's think a little bit about where they came from and what that tells us. And so we put together this little bit of a sort of a map of kind of where languages came from. And I actually have the slides here. Is it okay if I share them with you? And
yes, please.
So these are the slides we developed at the time. We basically divided the world up into these 6 categories. And, I look at it today and I feel like, oh, this isn't perfect. Maybe I'd do it differently if I did it today. But at the time, the 6 categories we came up with were lone hardware vendors, so kind of who we considered ourselves to be at the time. Hardware vendor consortium, so cases where a bunch of different vendors got together and worked on a language. Independent software vendors, you can think of this as like people who just develop software. Academics, government labs, and then open source fanatics. And I don't remember how we came up with these 6 categories, but then we started thinking about, okay, well, what are the languages we care about and where do they fit into things? We started out with these languages, for those of you who can see the screen, that are in green. And I use the term language loosely here. Some of these aren't technically languages, they're libraries or pragma-based markups, but I'm just going to use language because it's a way of expressing things to a computer, and I think of that as a form of language. And so in lone hardware vendors, we had C, which I mentioned earlier, Java, which I mentioned earlier. C++, we kind of put on the line between lone hardware vendors and open source fanatics. SHMEM, which is a technology used in HPC that was developed at Cray, actually. Then under hardware vendor consortiums, we had Fortran, high performance Fortran, which had kind of been a big deal the decade previously. OpenMP, which is still a very important technology today. And then down in government labs, we had MPI and UPC, which at the time were 2 of the dominant ways of programming distributed systems, and MPI to this day still is. And so from there, we sort of took a step back and said, well, where did some of these things come from? Because in many cases, these technologies were evolutions of other things. And so we kind of came up with predecessors to those current languages. And so, for example, we started with kind of modern Fortran at the time, Fortran 90, Fortran 95. But we stepped back and said, oh, even though that is sort of a vendor consortium effort, if we go back to Fortran 66, that was from a lone hardware vendor as well. And so we looked at the history of these things and saw that not only did some of them obviously stem from single vendors, but in fact that sometimes if you went back, you would see predecessors to things that had become consortium efforts coming from single vendors as well. And then the third step we took was to take a bunch of other technologies, some of which were important to HPC, others of which maybe a little bit less so, but sort of captured other elements that we wanted and looked at where they fell. And by virtue of going through this exercise, at the end of it, he was like, okay, yeah, I'm convinced. We can do a language. And I remember one of the other things we talked about in that conversation was, but the key is that we don't just hang on to it forever, but that we also think that it's important to have it become a consortium effort over time, whether through open source or a vendor consortium or something like that. The idea being that, we think that it's healthier for language, better for the community, and that users will come to it more if it becomes more of a cooperative effort over time. And that's a little bit of foreshadowing there. But yeah, this is the exercise that led us to going from, no, we're not going to do a language, to like, okay, yeah, let's do a language. And that's what led to Chapel.
So there were kind of maybe two debates really close to each other. And one is whether or not Clay should start developing a new programming language. And then the other one is how to make it successful and widely adopted. So make it really worthwhile to implement it.